Okay, so to start this, we're going to use our TI Inspire. So go to graph page. First equation is 3, so y equals 3 or f of x equals 3. Press enter, hit tab, hit control divide to type a fraction, 1/2 x plus control divide 5/2. Oops, 5/2. And we want to find out where those two lines cross. And so we're going to press menu. I like to go to geometry, points and lines, intersection points, click on the two graphs, and it should give you the ordered pair, which is 1, 3. Remember this section, I want your answer to be in an ordered pair form when you do this. Before we graph this one, we want to solve this one for y, so it's going to take a couple steps. Let's add x to both sides, so this would be 2y equals x plus 2. I like to put that x term first. Divided by 2. So we get y equals 1/2 x, or x over 2, plus 1. So that's one of the equations we're going to graph. And this one, again, we want to get the x term to the other side. So 2y equals negative 3x minus 6. Divide by 2, divide by 2, divide by 2. You get y equals negative 3/2 is your slope, minus 3. So you've got your two equations now. Get this on the other side. Okay. So hit the home key, go to a new graph page down here at the bottom. Control divide 1/2 x plus 1. Press enter, hit tab. Negative, so control divide negative 3 divided by 2x minus 3. And I want to find out where they cross. You might even see it already, but I'm going to go back to menu. Let's go to analyze graph just for a different way to do it. Intersection. If you click somewhere to the left, so lower bound below, so to the left of that point of intersection, scroll to the right as long as that point's included in there, click, and you have the answer, which is negative 2, 0. You can always check your answer to make sure it works by plugging it into both equations, and it should make both equations true. Like this one's easy to see. Y is equal to 3. Well, y is 3. Half of 1 is 1/2 plus 5/2 is 6/2, which is 3. So that one definitely works. Without graphing, classify the system as having one solution, with independent, infinite solutions without dependent, or no solutions, inconsistent. So first thing you might want to do is just get this, kind of like we just did a minute ago. Let's get it in the same form. So we'd have 1/2 y equals x plus 8. Multiply everything by 2. Multiply by 2, you get y equals 2x plus 16. So we're comparing this one and this one. And really all we have to look at is the slope and the y-intercept. So slopes are the same. So that could mean infinite solution or no solution. There's either parallel lines or the same line. And clearly they're not the same line because the y-intercepts are different. So when the slopes are the same, so this graph would have this kind of a look to it. It would be like two parallel lines, basically. I guess it would be with a y-intercept that's positive. But two parallel lines, it's going to be no solution, which is inconsistent. So this one is inconsistent. And that's what you'd say is your answer. And here, solve it for y first. You get 3y equals x plus 15. Divide by 3, divide by 3, divide by 3. Get y equals 1/3 x plus 15/3, which is 5. So if you look at that 1/3 x plus 5, 1/3 x plus 5, that's the same exact line. That's going to be, graphically, it's like the same line. It crosses a whole bunch of times, an infinite number of times. It's always crossing. It's the same line. So that's going to be an infinite number of solutions, which is called dependent system. Solving system by substitution. You must show your work to receive full credit. Okay, so substitution. So you can really do it different ways. Here, I'm just going to take this first one and substitute it into the second equation here for, I guess, everywhere there's a b. So I guess I'm going to substitute over. Basically, I'm just setting these two things equal to each other, right? 2a minus 5 is equal to b, and 3 plus a I was going to plug it in there, but it's actually plugging it for b. 3 plus a. So if you solve this, you're going to subtract a from both sides. That's nice. You get a minus 5 equals 3. And then add 5 to both sides, you get a equals 8. We're not quite done. Right, we got to plug it back in here. So I'm going to plug it back in there for a. So 3 plus 8 is 11. So b equals 11. And so the ordered pair answer would be 8, 11 would be our answer. Double check it if you want. You're not sure. You're like, oh, maybe I made a mistake there. 2 times 8 is 16 minus 5 is 11. That makes sense. 3 plus 8 is 11. That makes sense. It works in both of them. So that's definitely the answer. So again, I want the answer in an ordered pair. You want to do like elimination or substitution here, or this one, substitution. Okay, so we need to do substitution. So I might solve that for x. So x equals 3y plus 3. So that is what we're going to plug into the other equation. So instead of x, it's going to be 3y plus 3. So we'd have 3y plus 3 plus y equals 15. So we had 4y plus 3 equals 15. 4y equals 12. Y equals 3. We're not quite done. That's not actually our answer, right? You got to plug it in here. So y is 3. X plus 3 equals 15. So x plus 3 equals 15. So subtract 3, you get x equals 12. And you always want to put put it in alphabetical order, x, y. So it'd be 12, comma, 3 is our order pair. Sorry, that's really sloppy, but I think you get the idea. Solve by elimination. So with elimination, you want to get the same variables like in this first one. You could multiply everything in the first equation, every term by 3, multiply everything by 2 here. That would work. But I've got it to kind of set up a little better here because the x's should eliminate a little faster if I multiply everything by -1. So if I do that, this becomes negative 4x, -3, and -6. And now I'm just going to add, right? So I get, well, the x's go away. You get negative y equals 5, so y equals -5. And then you just got to plug back in, right? So everywhere there's a y, you could plug in right there. So you say 4x minus 2 times -5 equals 11. So 4x plus 10 equals 11. So 4x equals 1, so x equals 1/4. So our answer is 1/4, comma, -5. If you're not sure, we could always plug it in. Like if we plugged it in the second equation, that would be 1 plus 15. Oh, wait, it doesn't work. Did we make a mistake? Now I'm curious here. So -5, that works in the first equation, right? 1/4, 1 minus -10. It's like 1 plus 10 is 11. The second equation would be 1 plus 3 times -15. 3 times plus 15 is not 6, so we made a mistake here. Sorry. So I know what our mistake was. Right here, when you add up -2 plus -3, you get -5y. And so when you solve that, so y is not -5. When you divide by -5, you get y equals -1. Okay, so now we're getting somewhere. So, the nice thing about this is on this test, if you make a mistake, you go, well, I'm just going to test it to make sure it works. And when it doesn't work, that's okay. You can just, plug it again, make sure it works. So you can always check your answers, which is really handy. So I'm going to plug that in for y. So I get 4x, sorry, I'm right out of room here, minus 2 times -1 equals 11. So 4x plus 2 equals 11. So 4x equals 9. So x equals 9/4. Okay, so let's check that. So 9/4. So that would be 4 times 9/4 is actually 9. Minus 2 times -1 is plus 2. 9 plus 2 is 11. That works. 4 times 9/4 is 9. Plus 3. 9 plus let's see, 9 minus 3. 9 minus 3 is 6. That works. So that actually works. So the answer is 9/4, comma, -1. It's kind of a tougher one, and to be a fraction there. Okay, we want to use elimination, so you really have a choice. And oh, wow, there's a lot of things wrong with this. So one thing is these two are not in the right position. Do y'all see that right away? Like you want to line up all the x's, line up the y's, line up the numbers and the equal signs. Everything needs to be lined up, and they're not right now. So I need to add 4 to both sides, add y to both sides. So right then we'd get 5x plus 2y equals 10. Well, we didn't change anything there. But this will be 4x plus y, because I added y to both sides, equals positive 4, because I added 4 to both sides. Now we're getting somewhere. I need to get the same, I like the exact opposite. So I'm going to multiply by -2 here. That should eliminate the y's. So the top equation remains the same. It's 5x plus 2y equals 10. But the bottom equation becomes -8x minus 2y equals -8. So everything got multiplied. The y's go away. You get -3x equals 2. So x equals -2/3. That didn't work out great, but let's see what happens here. So let's plug that into one of those equations. It doesn't really matter which one. So I'm going to plug into this one. So that would be 4 times -2/3 is -8/3 minus 4 equals y, or -y. So I want the same denominator here to be able to kind of combine these fractions. So it'd be -8/3 minus 12/3, which is -20/3, which is -y. So y equals positive 20/3. Oof. Okay, let's check it before we write down our final answer. So we'd be, this first one would be 5 times, so that'd be -10/3 plus 40/3 is 30/3. 30/3 is 10. That works in the first one. 4 times -2/3 is -8/3 minus 4, which is like minus 12/3. So -8/3 minus 12/3 is -20/3, and negative y would equal positive. So that actually works. So that is the right answer. So wow, this is really tough one. It's -2/3. It's a 2 there. It's really looks like a z, but it's a 2, comma 20/3. Sorry, it just gets a little sloppy writing this sometimes. So now you really have a choice which one you like to use. Maybe one seems a little easier than another here, and you can do that. I tend to like elimination better, so I typically will go with the elimination method. So like if you multiply this one by, let's just multiply by 3. So that first equation is the same, 4x plus 3y equals 9. Second equation will be 6x minus 3y equals 21. The y's go away, you get 10x equals 30. That's not bad. X equals 3. Plug it back into one of those other guys. So that's be like if we plugged it in there for x, that would be 12 plus 3y equals 9. Subtract 12, you get 3y equals -3. So y equals -1. So the answer is 3, -1. If you're not sure, you can plug those both guys back into both equations and make sure they work in both. Let's just try out, well, boy, that not a nice equation. So what actually, let's see what happens. So let's kind of get them in the same form. So I'm going to move that 5x over to the other side by adding it. So I get 5x plus 2y equals 22. And wow, I have 5x. Let's just multiply everything by -1, because I know that's going to be the next step. So -5x minus 2y equals positive 44. So watch what happens when I add these two things. The x's go away, the y's go away. So on the left-hand side, we have 0. On the right-hand side, we have 66. Is that true? Does 0 equal 66? No. So there is no solution, no solve. here for this one. So they end up having the same slope, different y-intercepts. It's not going to work out. So elimination does save some time there. I think that wasn't too bad of a method to use there. I tend to like that one better. Graph both equations and find the point of intersection. So y equals 4 is the easy one there. Hopefully you know that's a horizontal, not a vertical line. So it touches every point where y is equal to 4. This 2, if you remember, like that's where you want to like write down the ordered pairs. So like write down, 0, 0. Anytime there's a value in front, like an a value, start with the point you know and love. 1, 1, 2, 2, negative 1, 1, and negative 2, 2. And you could do a few more if you wanted, but I'm going to stop that. So multiply by 2. This is now 0. This is now 2. This is now 4. This is now 2. This is now 4. So I'm going to plot those points. So that would just be those 5 points would be, let's see, 0, 0, 1, 2, 2, 4, negative 1, 2, negative 2, 4. And every one of those points gets moved down 2 units. So this one moves it down. Remember that first one's a vertical stretch. So I'm going to go down 2, down 2, down 2. This one goes down 2 to there. This one goes down 2 to there. It's kind of a skinny graph. Has this kind of look to it. And it opens up. Oops, sorry. Getting a little sloppy there. We should go through those slope points there. And you got your graph. And so where do they cross? Well, they cross clearly here at this point, which is 3, 4, and this point, which is negative 3, positive 4. Okay, so we're going to subtract 3x from each side here, just to solve for y. So negative 3x plus 1, divide by negative 1, get y greater than or equal to change the sign when you divide by negative. This becomes positive 3x, this becomes minus 1. Okay, so always start with the y-intercept. Slope is 3, 1, 2, 3 over 1, positive. Up 3 over 1, down 3 over 1 the other way. It's a solid line, so you can draw a solid line there. And it's greater than or equal to, so it's going to be shading up above there, so kind of like that. Okay, so we've got to solve both of these for y. So this first one, we're going to subtract x, so it'd be negative 2y greater than or equal to negative x plus 2. Divide by negative 2, you get y less than or equal to, changes direction. That'd be positive 1/2 x, and not minus 1. 2 divided by negative 2 is negative 1. Okay, so that's one of them, and the other one is a lot easier. It'd just be y greater than x plus 4. So x plus 4, the slope is 1, looks something like that. Lots and lots of slope points, so we draw this line accurately. And it's a dotted line. And we're going to shade above that one because it's greater than, but let's just wait until this one. So 1/2 x minus 1, so slope is positive 1/2 x. Oh, wow, this one's weird. Okay. So this would be solid line. And this is less than or equal to that line. So I'm below that line and I'm above the other line here. So, wow, so I really need to extend this a little bit more. So if I extend to there and there and there, if I extend that dotted line, I extend this line, this extended. So let's see, above the dotted line, but below the solid line. So really this area right in there. So it's not like right in there is really our shaded solution. Make sure I got that right. Okay, so that is right. So let's go to 3x minus 2. Slope is 3. Looks a lot like one that we just did. 1, 2, 3, up. And down 3 over 1 the other way. Solid line, because it's equal to. And less than, so we're shade below. If you're not sure, you can always test a point. Here's what I mean by that. So let's say take 0, 0. That's outside of. So if we plug in 0, 0, that ordered pair, so that would be 0 less or equal to 3 times 0, 0 minus 2. Is that true? Is 0 smaller than negative 2? No, that's not true. So 0 should not be in the shaded region. It's not. It's outside the shaded region. So that's the graph for that one. So by graphing, so we're going to go ahead and just graph these. So this would be, this one, again, solve for y. So y less than negative x plus 4. So that looks like 4. Slope is negative 1 or negative 1x there. So negative 1 is the slope. And it's a dotted line. We're going to shade below that in just a minute. 2x minus 1. So slope is 2. Oops, right here. I missed that point. That's going to be a solid line. That's going to be shading below. So below both lines. So below the dotted line and below. So let me just extend this out just so you see it a little more. So eventually those are going to cross somewhere up there. The shaded area is below both of those lines. So all of this is shaded and there, but it's actually going to be topped off by that dotted line when it gets up there, and the rest of the time it's topped off by the solid line there. So it looks something like that. And this one, 1 half x minus 1, so slope is 1/2. Plot a few of the slope points. Solid line because it's equals to. We're going to shade above that one. And this one is a graph that's been reflected downwards. So a V shape that's reflected now, it's looking like that. And you're moving it 1 to the left and 2 up. So I'm going to start with the vertex the way I'm going to do it. 1 to the left and 2 up. There it is. Again, you can multiply that. So instead of going up 1, down 1, it's going in the other direction here. Slope is 1 and negative 1. So got a bunch of slope points. It's greater than or equal to, so these are both solid lines for this V. And the shading is below that, so below the absolute value graph, but above the linear line. So all of this looks to be the double shaded region there. And we're almost to the last problem here, so that's good. A couple problems. So this one is going to be negative x plus 3, so y-intercept of 3, slope of negative 1. Bunch of slope points here. And that's a solid line. Try to hit all the points I can. It's going to be shading below in just a second, and then negative 1 half x plus 2, so that's here. So I'd like that they cross on that point. So this point, this point, this point's going to be, remember these just tell us first quadrant. So as soon as I graph this, looks roughly like this. It's below both of those lines. So the shaded region really is, it's not really a triangle, it's like a quadrilateral there, where this point 2, 1, this point 3, 0, this point 0, 2, and this point 0, 0 are the endpoints of the polygon of this solution region there. So then I'm going to plug each one of those in there and look for the max. So where does this give me a max value? Well, 0 gives 0. 2 for y would be 6. So that would give you like 6. 3 for x would be negative 12. There's a negative 12. This one might be, let's see, this would be negative 8 plus 3 is negative 5. Negative 5, sorry, that's negative also. So the biggest number there is 6. That would be the answer for that one. Or the ordered pair 0, 2, depending on how they phrase the question. Fifth one, negative x plus 4. Negative x means it's sloping this way, right? Solid line, best you can. Negative 1/3 x plus 2. Ooh, I like that. It crosses right there. So we're way out there. So draw that line best you can. It's below, both of these are below, so less than is below. So, but it's in the first quadrant. Again, that says first quadrant. So all of this, the shaded region, the points we have to check are 4, 0, 3, 1, 0, 2, and this other endpoint is 0, 0. So we're going to plug that into this function, and we're looking for a minimum in this case. So 4, 0 would be 8. 3 would be 6, plus 3 is 9. Oh, that's bigger. This would just be 0. 2 times 3 is 6. So the biggest one, oh, we're looking for minimum, sorry. Minimum is 8, 0. So 0, 0 is the minimum there. It's kind of